Welcome, people, or everybody. I'm Maria Barnes, and I'm the chapter president of Access Lunchtime. And with us here today, we have Luke Chung. And Luke is the founder of FMS. Way back in 1986, he founded that and is the primary author of many of their tools. They've got quite a famous set of tools, including Total Access Analyzer, Detective, Emailer, and Statistics. And besides providing consulting services directly to clients, he's a Microsoft Access MVP and has been for quite some time, Luke. I don't know if you could tell me how many years, but he's a graduate of Harvard University and has a bachelor's in engineering and applied sciences and a master's in physical oceanography.
Great, Maria. Well, thank you very much for giving me the opportunity to speak before the group. Delighted to share some of the experiences that we have in doing data analytics. Hopefully, people will learn a few things that they can apply to their immediate needs, and beyond that, learn more from it. And then I will provide the slides and databases that I use in this presentation afterwards, and I'm sure Maria will find a way to share that. The topic today will be Microsoft Access Data Analytics and Analysis, Query Tips and Techniques. Limited amount of code, a lot of things on using queries better. So hopefully you will find that useful. Just a little bit about me. I'm the president founder of FMS. Maria gave me a very nice introduction. Thank you very much. I've been a designer and of several of all our products related to Microsoft Access, primary author of several, and have created a whole lot of different Access applications, SQL Server, .NET, so on. We've been in business for 37 years, which is unbelievable. We're located in Virginia, just outside Washington, D.C. We have a variety of Microsoft Access related products, 12 products, tens of thousands of customers around the world, and many large companies to help with the whole life cycle of Access development, maintenance, documentation, system administration, and so on. Related to this topic probably is our Total Access Statistics program. That's our data analytics program. I am the primary author on that, so I have a very fond place for taking the data that one has and maximizing value from it by being able to do more analysis and simplified ways of getting to the data that you or your end users need. So if you haven't visited our website, please do, fmsinc.com. We have lots of free resources, developer papers. We have a whole area on queries, our query center, upsizing if you want to migrate your data from SQL Server or Access to SQL Server, both on-premise and into the cloud, and then also some tips on Outlook. So an overview of what I'll cover today. Basic query tips. We'll do some record selections, frequency distributions, not-in queries, union queries, and see how those can be used in various areas, crosstabs and reports, and the challenges associated with that, using temp tables and temp databases as needed, data cleaning, and some modern charts. And of course, data analysis and queries covers a very, very wide area. So this is just a sample of some of the things that we've used that may come in handy, and hopefully you learn a few things. So to begin, record sampling. Record sampling is being able to select a subset of records from your table. So an example of this, and I will show this, let's see. Okay, so here, okay, so sample nth record. Here's a query. Let me open up the table. So here's a basic table. It's a table of U.S. presidents. So there are 46 of them. And let's come in and choose every fifth one. So let me continue. We can just run this, and we'll see that we grab every fifth one with a very simple query. Requires no code, and it is just using the mod function, which is in this case, the present ID, which is numbered, mod 5. Let me show that better so it's clear. It shows a number. 1 is 1, and then when it gets to 5, it becomes 0, right? So it just takes and divides by 5 of whatever the remainder is, gives it a number 1, 2, 3, 4, or 0, depending on 5. And so when we set the criteria to be 0 for every 5, we would just get the 5th, 10th, 15th, 20th, and so forth. Very easy way to get every fifth number or whatever number you want to set as the mod. Right? Sometimes you may want to, instead of the 0 to get the fifth one, you want to start with the first one, right? So you go 1 from George Washington, present number 6, 11, and so on. And so that is a very simple way to get the nth record from a table. Another example would be to get random records. So let's just say I want to get 20% of 1/5 of the record. And so I can use a random function, which is a VBA function, RND, pass it the ID. It really doesn't have to be a particular value, but you want to pass in a value for every record. And I will give all the ones that randomly have a value, produces a value between 0 and 1, and give me all the ones that are less than 0.02, which would be 20% of them. And so I can randomly choose, in this case, it comes back with 10. If I hit Shift F9 and repeat it again, I will come up with a different set of records, and they may vary in terms of how many there are. And to see that better, let's move that forward and just see the value. The random function just comes back with a value for each row, because we pass in a field value. It calculates a new value for each record, and we just put a criteria on it. And obviously, if we click on it, it actually recalculates each time. But if we have a criteria on it, like we did before, less than, or we could also do greater than or equal to 0.8 is the same. It really doesn't matter what the value is. We just do that. The value that's shown actually isn't the actual value when it calculates the record, so that can be confusing. But the point is, it really doesn't matter. We're not getting the value of it. We're just getting, say, 20% of the rows to appear. Now, we want to make sure that we actually pass in the field value, because if we don't, and we just use this random function without passing a parameter, essentially, it calculates the same value for every single row. And therefore, you will get 0 or all of them, because it doesn't recalculate a different value for each row because no parameters passed to it. It's just calculated once. I guess the query is smart enough to do that. So if we say, hey, we only want 25% of them when we run this, we will get 0, or if we hit, recalculate it, we'll get all 46, which is not what we want when we're saying we want 25% of the row. But that's just an example of random record selection. And to use the random function, RND function, to go with that. Right. So, frequency distribution. So another way you may want to look at data is to bin it in categories based on certain values. A common example of this would be age. I want to bin people in their 20s and 30s, 40s, 50s, whatever. Or I may want to bin things for people, under the age of 35 and in different categories beyond that. There's a function, a VBA function called partition, that is particularly useful for this. Partition function allows you to pass it a value, a number, and then specify the start and stop values for the range and the interval. And that allows it to automatically create bins for your data categories. So let me just show that. So here I have patient data. Let me just show the patient data. So this is just a row, 200 rows of people what state they're in, what gender, age, weight, cholesterol, high, low blood pressure, I don't know. So just patient data. And we want to see on a very basic level what age group they're in. So let's just look at this. And we can, with one query, no code, calculate how many people fall into each age category. So between 20 and 29 is one value and so on. And the partition value is we're just passing it to age field. We're saying we're going to go from 0 to 100. Nobody's more than 100. And group it in bins of 10, right? And then count. So it's just a straightforward query. And we can count that up. We can change it instead of groups of 10. Let's change it to 5. And we would see it in groups of 5 to automatically see where our data how our data falls in. So it's a very useful way to see a summary of what's in your data set by using the partition. It gives you an understanding of what you have. And of course, you can do it on any field, just like you would. I mean, this is just like the standard. If you just did it based on age, right, the common group by age, you would see it by age value and then the counts, right? So the frequency distribution with the partition allows you to change that. Now, another thing that you can do with this partition is to limit it. So instead of starting at 0, we can say, oh, I'm most interested in the categories 31 to 50, and I don't really care about the data beyond that. So if I look at this, I can specify that, and it will automatically calculate all the values below 30, automatically really goes into 0. And then within that group, that range I specified, do it in groups of 10. And then beyond that, give me that other value. Similarly, I can change it instead of 10 to 5. So this gives you kind of a higher resolution of seeing things within the range you care about and then putting into a bucket all the things outside that. Right. I see a question that says, does the partition work with alpha characters? And the answer is no. You would need to convert it into numbers. So this is for number ranges. So that's how partition works. So it's very straightforward. You'll be able to do that very quickly. You don't really need to write any code to see that frequency distribution. Now, you may want to be able to do frequency distributions in bins that are not equal. If the partition requires each group to be, in this case, 5 years or 10 years in the example that I showed. But maybe you want a different grouping. You want to have it set up. You can define it and also have a different value associated with that. And we can show it this way. Now we can create a table that you can specify whatever values you want, age, whatever. And maybe we don't, yeah, so you specify, and in this case I have integer, so it's easy to be able to do this. Whatever categories that you want, and then when you run this, you get these values grouped that way. This is a two-table query without an explicit join between the tables. We have our patient table, we have our age group table, which is this, which has a minimum and maximum for each of these groups. And what we do is we specify to connect them together the age field from the patient data, where the minimum and maximum are these values. And we do the group name here, the group name from the grouping. We count the patient ID here, and we sort it by the minimum value. You could have your own sort field or something else in here if you want to define that more explicitly. Again, no code required. It's just joining two tables. If you want to see the SQL Server, SQL queries, it just shows this is your regular count for the patients. There's a where clause that does the minimum, maximum, and it groups by that. So again, all this will be provided. You can play with this yourselves once you get that. That's an example of doing the grouping by defined groups. Not in queries. This is another area that comes up. I want to see all the data in a standard link that will require them to be together, or I may have a table where I don't have that. So, okay. So I have a states table, right? So this is a list of states, U.S. states. There are 54 of them. They're territories and things like that with their initials. I have my patient table, which has a state column in here. And if I were to do a regular join, which is this, I can see for all the states their name. Whoops. That. Wait, let me do this. Let me share this with all states. So this will show all states with their full name and their values, including states that have nothing. And this is done through what's known as a left join. That I can, if I link these two together, because I want to see the state names and say the initials, this would be my data. These are the people that are in those states and the values associated with that, right? Because I wanted to translate the state name to the full name instead of the abbreviation. But if I wanted to see all the states, including the ones that I don't have, I want to include, it's known as a left join, to include all of the records from the states table, even those that aren't in there. And I can look at that and it will show me, give me all the state information and link in the values that exist. Right? So this shows me those that are included and not included. If we were to look at a sequence string, we would see that it uses left join to make that definition to show one side versus the other. If I had them together, right, the default, and what people normally have when they link together is the inner join, right? So left join, right join, inner join. So this just shows the ones that match, and the left join shows the ones that don't. So the other thing is the not in. So if I were to do the not in, give me all the states where I don't have any patients. This is where I use the left join. And in this case, I would have on this side, the patient side, where the value is null. It could be the ID is null. It really doesn't matter. It's null on this side. And it will give me all the states, in this case, 42, that don't have data, as opposed to these were the 12 that did have data. So these don't have any patients, and these have them. Again, very simple query, doesn't require any code. I can automatically see that, right? And this is a not in query using an is null here. Now, one of the things to be more careful about is not in query with criteria. So if I want to look for all states in this case without any patients over an age, and let's say 60 years old, that's a different kind of query. So I want to show how that works. So if I have a query, this is just a simple query, the patient's data, give me all the states grouped by where age of patients is greater than 60. This will give me a list of all the states that have that. This is not a list of all the states. I have 12 states with data, and I have 9 states with patients without data. So there are 3 that don't have it, right? And so I want to see all the patients, all the states that don't have patients that are that either have no patients or only patients that are under 60. So what you can't do is do this in the outer join query that we were looking at, where you put a criteria in the age column, right? So if I tried this and I said, okay, give me all the patients where the age is greater than 60 and then link them together so that they're null, right? Which is kind of the criteria I had before, right? I will get nothing. And that's not the correct answer. The challenge is that when Access has a criteria on this side, it doesn't work in the same way. So what you need to do is you need to create a link that is, let me see what I have. States with no patients here. So now I can link to this, where I have patients, all states, linked to this query that gives me the list of states that I have patients over 60, and then give me the results that include all of those that don't have it, right? So, and I have another query here. It's really showing these 3 states that I have where the maximum age is under 60. So Alabama, DC, and Pennsylvania. And that would be included in here, Alabama, DC, whatever, is among the states where there's none greater than 60. Let me go back to the patient data so you know what I'm looking at or showing. So if I were to take this patient data, state and age, and sort this, you can see in Alabama, there are only a couple here. The oldest is 28. California has 167, so that wouldn't count. DC 56 is the highest, so they fall under the under 60 category. Anyway, so that's an example of how to do that. Union queries. Union queries is the ability to combine 2 select queries essentially into one. And this is useful in some areas where you have totally different criteria that may be in one table and or you're combining data from 2 tables into one. So let me go back here. So it can be a it's what one would call subqueries, each piece of a query combined together in a union. They can be from individual or different tables. Each subquery is like a different select query. The first subquery's fields define the fields in the union, whatever those field names are, also defines the data types of the columns. And then you use those to combine them together. There's union and union all. Union all as the criteria will eliminate duplicates. And then you can specify the order by at the end to sort whatever comes through. Union query to show none. So a common thing that one may use a union query is a lookup table, a lookup column that you may have in a field where you may want people to specify a blank value. This can be on a form or very simply on a lookup column in a table where you can explicitly have a none value, right? And so this can be done very simply. So let me show you this with a simple table that we have. Let me close columns. Yes, I modified everything. Save those. So this is a lookup table, and it is using, I think this is from Northwind, the employees table. Right, here's a list of names, and you may just have a table where you just want to fill in data. Right, so you can have a very simple lookup. That's the common lookup that you would have if you tied a table with a combo box that pointed to the employee table, right? And you could have an ID and show first name, last name kind of thing, right? And so you could add more data, but wouldn't it be nice if the field allowed no values to have in here instead of the straight lookup also a none category, right? Because when you specify this without that, it's kind of hard to choose. And then you can choose none, and it's tied to a null value, so it doesn't matter. I also have a list of states using the states table, but we can also do the same thing where we add a null at the top, a none at the top, right? And so that's pretty simple to do. Let's just put this in design mode. Let's look up. We have a combo box. I know it may be a little hard to see. I can't change the font size for the table designer. Employee ID, where it's just the typical lookup list. We take employees. That ID is the bound column, and then we create first name, last name is what we would show, right? That's pretty standard, but it shows everything. The difference would be on a union query, we can take that and we still have this same part up here, which is the union, the original list, but we add with it a new item, a union, which is null, and then the none value. So the null corresponds to employee ID, and the string null corresponds to first name, last name, the employee name. And then we order by the employee name, where none will be part of that. And we did this against the employees table, but you could do it against any table, or you could have a table with just one row. And then when we look at that, then we see that the null is up top. There's a null value for employee ID with the description that's displayed as none. And so that's a simple way to be able to use a union query to help with data entry for explicit null values when people may not need to specify that. Crosstab queries. So if you're looking at 2 dimensions, crosstabs are very powerful. They allow you to essentially do a data transpose. This is very similar to what people are used to in spreadsheets. And oftentimes people take data from spreadsheets that are essentially non-normalized and in a crosstab type layout, and you need to bring it into Access or into a database. And then from a database, you will need to show it in a crosstab, either a view on a screen, could be in a query, could be in a form, could be in a report. But it gets a little challenging with crosstabs because column names become a problem if you need to put it into a formal report, because the column values, the field names essentially are based on the underlying data, and that can change over time. Let's look at Crosstab. So here we're looking at our patients, and we're going to look at, let me just find columns. We have gender, which is a row heading, state, which is the column heading. We're talking about crosstabs. Cholesterol is going to be the value. We're going to have a row heading that shows count. Do that over here so you can see the number per state. And then we'll also show the average across the whole state. So this is what it looks like. So we have here by gender, that's the row heading, how many are by gender, the average cholesterol, and then by state, we can see what the average is for each of them, right? So a very powerful way to see a summary of this data across every state, right? And you can flip them, that the states could be the other way around. But the challenge here is you end up with lots of columns, maybe for states that you don't care about, or values you don't care about in the column headings. There is a way to control that, which is to limit columns that come back by being able to specify those with the pivot command. The pivot command, this is the same exact query, but the pivot command limits what values are in the column field. So in this case, I just want Virginia, Maryland, DC, and I want to show them in that order. It gives me that, right? Notice that the original one shows them in alphabetical order, but with the pivot command, the in clause, I can specify which states to include, and by default, it excludes everything else. And I can even specify data that doesn't exist. So I can have a column say XY, and it will always show up in that. And this is very powerful because if you have a report that is driven off of this, reports are going to be requiring fixed columns, fixed column names. You may want to specify this. So even if, in this example, the data comes back and there's no Virginia data, you will still have a column called VA, and your report or form that uses it won't get broken. So that's how you use the pivot in clause to be able to control the column field names. So crosstabs for reports. So using reports, using a crosstab as a record source of reports can be challenging. And that's why this pivot command is so important, to make sure the specified required columns exist. And the example I'm going to show here is a kind of like a financial report that shows on a monthly basis the summary by, in this case, country and sales. And this comes from, let's see, do I have this here? A different here. I think with a different database. crosstab data where it shows, I think this is Northwind data, by country, by month, the sales. Right? And so this is a very simple standard crosstab. I would be able to show group by country as the row heading, sales, which is based on the data unit price times quantity, 1 minus the discount is what was sold. And then the format, in this case, which I want to show year dash month. And using the format command on the order date, that's the value that comes back. And I can use that here to automatically show those columns, right? But that's a challenge because the report needs to be flexible enough to support any date, not just this specific date. And you don't want to create a report, or you prefer not to create a report where you change the column names each time. And so there's a very simple technique to be able to do that. Again, with no code, I can create a monthly report, and I can say, oh, starting in January 1st, 2022, give me the report which shows, bigger, by month, what the sales were by country. Right? And I can show that report again with a different criteria, say 23, and it automatically adjusts for that. Right? So now it shows on 2023. Now the key here is there is no code involved to do this. There's no code to do that. It's just based on criteria. So here, let me show the properties. So this is the query that is the data source for it. And it has a parameter, which is the order date, right? So we want to specify parameter, start date, date time. So whatever date time criteria we specify, those are the orders that we're going to get. And it's tied to the order detail, which are the Northwind tables. We can, based on the order table, we have the country that it goes to, and we have the sales. That's calculated based on the order details table. Now, the key here that we're doing is we're creating an ID value that identifies these months from a number between 1 and 12 or beyond from the start date. And just to see that, what we're saying is, okay, let's say I start 6/1/23. It will show a value 1, 2, 3, 4, so on for the next 12 months from that start date. Right? And based on that, because this will always come back with a record pivot in 1 through 12, I can have a report that goes off of that. Now, this criteria here is the order date, which comes from the orders table, year of it times 12 plus the month number. That becomes one number. And I subtract from that the year and month number from my start date, plus 1, so that it adds up, the first month is included. So I'm basically taking the year month of the record, add that up and subtract it from my start date. And now I'm going to get a value between 1 and 12 based on my pivot. And then I can base my report on that. So, so this report will work for whatever, let's see, 1, 2, something like that. So based on whatever number is entered in as the parameter, it will pass that on to the underlying query, and I will automatically get this monthly summary report without having to create a different one for every date range. Now, the same thing can be applied to quarterly. So using the same criteria, I can use a quarterly report, and it will show, in 3-month buckets, 2022-1, Q1, Q2, Q3, Q4, and so on. So using the same concept, we have this quarterly report, and we have a table that instead of the year criteria, we multiply times 4, and then we add the order ID using the format. It'll come back with a 1, 2, 3, or 4. based on the date and subtract that out. And here in the headings, we just use the start date. And then we see in the start date, we just add Q1 for that second column. Here's Q2, Q3, and so on. So this will support any quarter. And we have a similar one for weekly. So let's see. We can do one for weekly if we want to do that, just again using the format function that Access has or VBA has to get a week number. So that's just an example of how to do these quarterly reports. And we have a web page online to be able to show that. Temporary tables and databases. So temporary tables are sometimes useful and can be created to process things, to show reports on forms and reports, and can be specified based on user criteria, right? The time range, maybe they choose a customer, country, whatever it is. And it allows you to create things and aggregate them for display to the user. And this is a really powerful way in a split database environment to keep this data on the front-end database so that each user has their own temporary data as opposed to sharing data on the back end. So, so consider using this sometimes if you're going through intermediate steps. Sometimes you may need to do something and process things before you go into more details afterwards. And you don't want to lose that while the user is running your application or a process where there may be a flow where multiple things are solved. We've also seen situations where temporary databases are used. So a temporary database can be very important if you're creating a series of reports or you're creating a series, doing some analysis on data that could change during the day or during the process, right? It doesn't work if you need to print out 10 reports and your first report doesn't tie to your 10th report because the underlying data changed, right? That's hard to explain to people because in what order you printed out the reports. So in some cases, we've created temporary databases on the back end that could be end of day, right? So of all the data that we had, it was based on end of day yesterday, and reports or other processes are based on that. You could put in criteria on all your queries and things like that to specify that. So there could be one way of doing that, but sometimes that's not exact because people delete data or data may get modified during that time, and you may not have accurate data again while you're using or running your reports or views if the underlying data changes, right? Because data that was yesterday may change today. So historic data may change. And so sometimes it's just easier to have a separate backend database and maybe your front end access application points to that database instead of the live data for doing some of the criteria. It also offers the ability to pre-process and summarize complex things into tables that can be used to drive your reports and forms much faster than if you had to do that from scratch on the live data. So data cleaning for analysis. Oftentimes we receive data that isn't exactly what we would want to put into a database. Sometimes the data may have carriage returns in some of the fields, or you need to separate out data, first name, last name, for instance. And there are certain functions in VBA that can be applied to inquiries to simplify this process. There's a replace function, which is useful for replacing carriage returns. There's a split function, which allows you to look for a string, say a space or a comma, semicolon, whatever, to decide to split data. There's in-string reverse to look for the string from the back forward as opposed to the front forward, left, right, and so on. So the example I'm going to show you here is again, a list of presents, but from the original data and how it got cleaned up. do this. This was the original data that we got for the list of presents. I think we got it from maybe it was Wikipedia or something. And it was a list of the name, how long they lived, their birth year and death year, what term they had in office, what political party they were in, what elections they were in, who their vice presidents were. So not exactly what we would want in a database, in a table. Also gets a little complicated because some of the presidents are still alive, so they don't have the birth year and end year. They happen to have the letter B period space and then the birth year without the death year. Okay, the data is the data. So some of the things that we can do is clean the data. So we can very easily with a query. Essentially, this was the original. This is the cleaned up data without the carriage return. So if you remember here, we have this. There's a carriage return in here that split it across two lines. We can replace that to clean that up, and so that's a simple way to do that. And let's just look at what we call president cleaned. We just replace in this what was named life column with this is the VB carriage return line feed, character 13, character 10. Can't use the constant VB, CR, LF in a query. And then we're going to replace it with the space. So anytime it sees a carriage return line feed in the field, it will automatically change it to a space. And so that cleans up like the president cleaned, term cleaned, or party cleaned, things like that, these columns, so that at least they're in one text field, right, without carriage returns inside. Well, the other thing that we would like to be able to do is, based on that query, so this is a query on top of a query, let's change so that we can split the president's name from the life. And so what we're doing is we're taking this value, and where we see that parentheses, we're going to split this column into two. And so now we have a column that just has the name, and then another column that has the life of when they lived and died if they're already. And then we can do another thing, which is let's split the first name, last name of the president's name. So we can take that and we can, based on the space, the last space, we're going to take everything to the right of the last space and make that the last name, and everything to the left of the last space and make that the first name. And so, in this case, we're lucky there were no juniors or the third or whatever. That would make it more complicated, but we're looking for a last space, and then we do a split based on that. So in this case, the last space was using the in-string reverse function on the president's field, and we look for the space, and that's the location of the last field, last space, and that's what we use. Give us everything the last name to the right of that, the length minus that value, and then for the first name, everything to the left of it, right? So that makes it easy to split that. Right? Now we want to look at the year that they died. So this was, again, going back to the second one, we have this, we got to this level. Well, let's split the year so that we have their birth year and their death year as separate columns. And so we can do that through just, I'm just showing some steps here. We're going to get rid of the left parentheses. We're going to get rid of the right parentheses. We end up with this. We want to split this, get rid of this B item, which this data set had as a special criteria for birth, right? So we take it from here, we take it to there, and then we want to separate out the birth year from the died year. And we want to handle it properly so that if there is no death year, we have a blank value as opposed to a fail. And I just wanted to show that as an example because it was splitting it on the dash. And in these, they didn't have a dash. So we don't want to catch that. So the bad one was to look at that, what we call nobody in string, where there is a dash to do it, but really we can use an if statement. Oops. If statement to make sure that there is a dash, and then therefore use that criteria, otherwise use a blank value, right? So that way, these are the correct ones. This is the bad one. Okay? But then taking it another level, we want to take those and make those, because these are strings. We want to change these to integers. And so what we can do is based on that, this is the birth and died years as integer as strings. We want to convert those to integers, and we can do it using the CINT function, convert to integer. And then again, if died is equal to 0, if the length is 0, it's a null value. Otherwise, change it to a value. So this is what's useful, because in the end, we want those to be. And then we take all this, we combine together all the different queries, and then presto, we start with this, and then we end up with first name, last name, birth year, died year. Because they're integers, we can now calculate age, and we've cleaned up what party they're in. And so that can be then used in an append query or something like that to put into a table where you would be able to use it. And so this is just kind of an example of a process of cleaning up data that can be helpful. Again, you can, obviously your situation will vary, but oftentimes we get data that's formatted funny that needs to be cleaned up before we can do more work with it. Modern charts. So modern charts were introduced, Access 2019, it's in 365, much better appearance than the old pixelated original sets of graphs, much better VBA supports. It's a lot of different chart types, bar, column, line, pie, combo. There is no XY graph. There's some data label limitations. There's some limitations I complain about, but still, the UI looks much better. And you can create some nice things that you otherwise couldn't. So here I just wanted to show an example using, again, the president's chart. We can show here is the president's party by the number of presidents by party. We could actually add a data label here that would show how many were in each party over the years. Right? And this is the default. It just goes against the president's table, the raw data, and the columns are sorted alphabetically. You can imagine this is like a crosstab in the background. So that's useful. But I really don't like this, because what I really want to see is the data sorted by party. I don't care about these little things, little parties. So overall, from a data analytics perspective, I'd like to see it from small to large. And I'd like to show the label so I can say, okay, there have been 18 Republicans, 16 Democrats, 4 Whigs, 4 Democrats/Republicans, unaffiliated, as George Washington, and different other parties that happened one time, I guess, around the Civil War era, whatever. And so this is another way to look at it. And the way we can look at this is we can see the criteria here. This is the data for the first tab. It was from table presidents. The second one is from query president's party. And so here we took the table presidents, we did a summary query group by party, and sorted it in descending order. And the graph respects that and shows it in that order. Right? So that's nice. But really, when I'm looking at this, there's too much noise here. I don't want these little things. What I really want is to be able to see it in a higher level. So I can see these are the Democratic Republicans. There's a Whig Democratic Republican, and I want to lump the others into an other category. And this is kind of the way we were doing with the frequency distributions, a categorization type of thing. And so I created a table with parties and the alternative that I want to use in the query. So this is how I created a query that showed it using that. where I linked it on presidential parties and then use this alternative as the column that I would be viewing. Do that. Show this, right? But maybe I don't want that. Maybe, let's see, what I have. Whigs, Democratic, Republicans. Maybe Democratic, Republicans should also be other. So I can change it here, and then when I recalculate, I would show that as the other. And then when I come here, I don't know if I have to refresh. This other category now contains that, and I can just kind of focus on what's important without losing the fact that this other data existed. There's some other ways to look at the data. It can be a pie chart that would show you the numbers in the different categories. You can, so has the count there for each of those. It can be percentages. This is really ugly. Not a fan of this because it doesn't show it. And it doesn't show it with a percentage sign, which is a limitation. There's no formatting of it. And then the other is using a percentage where I actually created a query that showed the value as a percentage and an integer of that value that I can use to map onto the graph. Programmatically, you can change things. Right now that's bar column clustered. It can change it to bar. That can be changed. You can change it to a pie. There's some really nice things that you can do programmatically that weren't possible before. So that's a big plus from that. As I mentioned, there were additional resources on our website. Hope you visit that. A whole bunch of free papers and resources I've written on queries, the different types of queries, dealing with non-updatable queries, which comes up from time to time. And if you really need advanced statistical analysis, our total access statistics program does that with regressions and correlations and percentiles and those kinds of things that go beyond access queries. And social media, we do a little blogging, Facebook type stuff, Twitter or X now, email newsletter. I know we haven't sent one in a while, but join if you want. And that it is. That's it. Open to any questions. Hope that was helpful. Thank you very much for the opportunity to share.
Thank you, Luke. There were two questions in the chat that I saw. The first was about your query that had the show all the states that have no data or those with ages less than 60. And the question was whether or not you could just put the or add a null as an or in the where statement and have that work like that. Does that make sense?
In the not in query, I think I'll have to get back on that. I'd have to play around with
Look at that. Okay.
To see. So,
yep.
Yeah.
Fair enough. And then the other question was wanting to know your preference and how you avoid database bloat in the front end if you're using temp tables in the front end. And there was some number of opinions and people gave different techniques they used, but Neil would like to know what technique you recommend or you are using.
Right. So if you're using temp tables, I mean, it would be nice to clean up afterwards if you have a lot of data in the tables, right? Put away your toys. So maybe after you display the data and don't need it anymore, empty your temp table. And then you can set up your front-end database to always compact on cloud. So that's an option that an Access database has. So when the user closes the database, it will compact that and hopefully make it small. The other way to do that is we usually have a front end. The front end for each user could get updated each time they start. So we usually have like a startup. Some people have a shortcut or whatever. We use our tool like the startup program to deploy our applications. And then when users click on it, it automatically replaces their front end database with whatever the master database is. So at least each time they start, they get a clean copy. And that way, if we update the database, the front end, they would always get that as well. We actually have a way to not update the front end if, say, the version ID didn't change, so that we don't override it each time. And that may make sense because the front end may store the user's last set of preferences. So there are ways to work around that. But if you have a compact on close, that should clean it up each time the user exits the front end application.
Perfect. Thank you. We're actually taking a break for June and July, so we'll have the next presentation at the end of August. George mentions that we have 2 new AUG groups that are forming, one in Italy and one in Australia. So that Australia one should be interesting. I don't know if does he have a time for that set yet, George? Do you know? I don't know if you want to.
Not off the top of my head. I think it will be probably the same time of day as mine, which is 6:30 Pacific, because that's like midday for him.
Okay.
In Australia.
So it'll be like Australia lunchtime?
Because he plans to focus primarily on SQL Express.
Okay, great.
And so my term from him, instead of being a chapter president, he is going to be the Wizard of Oz.
Aha.
He hasn't told me no yet.
Oh.
Alessandro's will be about the same time as this one, and that will start in, I think, September.
Okay. Thanks, everybody, for another great season. Again, we're going to take a 2-month break for this particular group. There are some of the Access User groups that do go all summer long, but I will see you again at the end of August when we are going to talk about web APIs and how to access the Microsoft Graph, do things like email, calendar, contacts, and things like that. So look forward to seeing you all in the fall. Bye-bye.
Bye-bye.